Okay, so we are now in exercise 9D. This is question 2. Let's read it. Epsilon, my sample space, is 1 to 12. A is equal to the multiples of 4, remembering that this exists within inside my sample space. And B is my even numbers, again, which exists within my sample space. Show these sets on a Venn diagram and use the diagram to find these things right here. The first thing I'm going to do is write out my multiples of 4 within inside my epsilon here. So it's going to be 4, 8, and 12. And my even numbers will be 2, 4, 6, 8, 10, and 12. Now I'm going to come down to my Venn diagram and put in these sets. So here I have A and B. Immediately, I realize that my multiples of 4 are all even numbers. So they're all going to exist within the intersection space here. 4, 8, 12. The remainder of my even numbers will be here. So I'm going to have 2, 6, and 10. So here I have 2, 4, 6, 8, 10, 12, all my even numbers. My intersection is my multiples of 4, and then the rest of my even numbers are just in the B space. And then finally, on the outside, I'll have my remaining numbers in my sample space, and they will all be the odd numbers. So I'm going to have 1, 3, 5, 7, 9, and 11. So if you wanted to double check that you've done it all correctly, you should be able to count everything up and get to your sample space. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Seems to check out. Now we have to find the complement of A. So we're now finding the complement of A. So that's everything not in A. So if I was to quickly give this a sketch with the highlighter, it's going to be everything here and everything here as well. So that means I'm going to get, let me put my fancy brackets. It's going to be 1, 2, 3, 5, 6, 7, 9, 10, and 11. So it's basically everything but my 4, 8, and 12. So 1, 2, 3, 5, 6, 7, 9, 10, 11. Perfect. Next, I'm going to find everything, so the complement of B, so everything not in B. So it's going to be everything in A, which is nothing, and then everything here as well. So it's just going to be my odd numbers out here. So I'm going to get 1, 3, 5, 7, 9, and 11. Next, I'm going to find the union of A and B, which is going to just be everything here. So it's going to be equals fancy brackets 2, 4, 6, 8, 10, 12. 4, 6, 8, 10, 12. So just basically my even numbers. Let me get rid of these lines. Now I'm going to find the complement of the union of A and B. So if you think of this as A and B, I want everything but this. Everything in my sample space, excluding A, the union of B, which is obviously just going to be these numbers right here. So my odd numbers again. So I'm going to go here, I'm going to go fancy brackets 1, 3, 5, 7, 9, and 11. Next, I'm going to find the complement of A with the intersection of the complement of B. So the complement of A is everything not in A, so it's going to be everything here. And then in another color, I'm going to find the complement of B. So it's going to be everything not in B. So it's going to be everything here. And hopefully what you can see is the only point of intersection between these is going to exist here. So these numbers, 1 to 11, the odd numbers. So it's going to be 1, 3, 5, 7, 9, and 11. Perfect.